All right, so yesterday we were talking about these trig identities, and I hope that you will always keep these identities in mind. And as I said yesterday, it is not just about knowing what they are, it's also knowing why they are like these. Like, for example, I showed you yesterday why we have cosine squared plus sine squared is equal to 1. What was the origin of this identity? Louder? X squared plus y squared is equal to 1 from the unit circle, right? So, and then I also explained yesterday, like, what about these two? If you understand this one, then what about these two? And we said, well, I told you I don't memorize those two. I generate those two, because I can simply have the first one and divide it by either sine squared theta or cosine squared theta. And I've got these two. And the reason why I rather generate instead of memorizing these two identities is because I don't trust myself. If you ask me why I don't memorize these two in my mind, I just do not trust myself in memorizing these correctly. This one is easy, these two. So I would take time to do my work like these to show myself. And they're not really used often. So that's also another reason why I don't want to waste my precious memory space to contain them. Now, I also did something new last night. If you subscribe to my YouTube channel, you may see something posted. I did yesterday's homework, and I recorded myself going through the homework. Because when you do these, you may get stuck, because you're still learning how to think of all these possibilities. And I want to walk you through all these possibilities. So at least you have some help. I want to see what more can I do to help you. Okay, so that's my my little service for you. All right, now, so let's go through these questions one more time. Okay, now, so again, yesterday I said you have to do mental math. Before you pick up your pencil to write down anything, you've got to think of all the possibilities first. And can you see any action that could be done? If you cannot see any action that could be done, do not write. Okay? This is my sincere advice for you. Now, here's another tip. I forgot to put this down yesterday. The other tip is this. Think in terms of sine x and cosine x. Okay, you can write this down. So it might be a lot easier to think of sine x and cosine x in many occasions. Not all, but many occasions. Okay, in many occasions. Like when you look at the part A right here, if you change it back to sine theta and cosine theta, it's a lot easier. And by the way, I hope you understand that theta and x is just unknown. So sometimes we use x, sometimes we use theta. And whenever you see some kind of square, that should trigger that Pythagorean identity. Okay. And the other thing I did in the video is to offer you multiple ways to do the same problem, because there could be more than one way to do the same problem. And I want you to appreciate all the ways you can do it so that you can select the best way. Okay? Just like, as I said yesterday, it's just like life, right? There are all the possibilities, then you choose the best route for yourself. So yesterday we also talked about having common denominator. Whenever you see fractions, entertain the idea of having common denominator. So let's go ahead and finish part D here. So we say, hey, can you make the left-hand side equal to the right-hand side? Can you make the left equal to cotangent x? Now, whenever we have something like this, keep the right-hand side intact. Do not touch. We tend to work on the more complicated side to make it simple. It's more challenging to make the simple side more complicated, but it's a lot easier to make the complicated side more simple. So in this case, we'll say, all right, let's just keep the right-hand side untouched. Let's just fix the left-hand side. And we say, well, what can we do? Well, we can, you see a fraction. So in your mind, so you could be thinking about, what if there is a common denominator? Well, what's going to happen to the second fraction if we pursue a common denominator? What would the numerator be? It becomes sine squared theta. Now, this is should be part of your mental math at the moment. And then you think about, now that we have a common denominator, let's think about this. Do not write. Let's think. 1 minus sine squared x. What is 1 minus sine squared x? Cosine, right? Cosine squared x, right? So you think about, so the numerator is going to be cosine squared x. The denominator is going to be sine x times cosine x. Can you see an action here? The cosine will get canceled out, leaving you with cosine over sine. And that is exactly cotangent. So now we can see how this whole problem would end. And then we can start writing. So this is all, the steps right here should all happen in your mental math prior to your writing. Okay. And this is probably the most challenging part of this topic. Yes. Simplifying. Cosine square x. Now, cosine square x means cosine x, the whole thing being squared. In case you don't know, most people may not know. So make sure you know that. That's how the cosine x got canceled out. And by the way, in terms of simplification, what is the standard of simplification? You may challenge me and say, well, is this simplified enough? Well, I would say the best indicator is how many strokes you're writing. Okay, compare this with this, which one's simpler? The right-hand side is simpler.
How do you get the sine squared?
Ah, you mean, wait, hold on. You mean this one? Or this one? Well, when you do the common denominator over here, well, what's lacking in the denominator? Sine x, right? So you multiply sine x for both numerator and denominator, and the numerator becomes sine square x. Okay? So concept-wise, it's just middle school, elementary school common denominator. It's just that the way we do it, the context we are working with, it's in high school, in pre-cal. But the concept, it's really just elementary school, middle school level. Okay? So let's see. Now, I do want to go over a few problems with you. I want you to work on number 4, number 5, number 4, number 5, number 10. Okay, number 8 and number 10. Let's look at these 4 questions: 4, 5, 8, and 10. Okay, for the next 5 minutes. Okay, you can work together and share some ideas, speak out your mind, your mental math. All right, so let's go over this together. Now, what I would tell you is that in all parts of your life, you need to have one skill. You have to train yourself on one particular skill, and that is called the associative thinking. Meaning that if I give you a word or an object, how many things you can tell yourself or tell people. Now, I only learned this after I started teaching environmental science in this school. I started it. I started environmental science in this in Clements. Yeah. What I learned is that you look at a picture. You look at a picture, and how much can you tell about this picture? And it turns out that everyone will speak different things, and that's all based on their background. That's all based on what they learned. And if you learn, then you have a very different vision. And the more knowledgeable you are, a simple picture could actually turn into a 3,000-word essay, if you have the knowledge. And of course, if you give a simple picture to a little kid, the kid would be like, just a picture. Now, so how does it relate to math? So you got to think about whenever you see something like square, like this, you have to think very instinctively like, wait, hold on. Does that relate to something? So whenever you see something like this, you should be thinking about, wait, hold on. I think I learned something. I learned this one, don't we? We know this. So you need to associate this expression with that, and you're like, wait, hold on. So what is 1 minus cosine squared x? What that is? Sine squared x. Right? So you move the term around, you subtract cosine squared x on the other side, then you have 1 minus cosine squared x. That it's equal to sine squared x. And then you think about what is cosecant x? 1 over sine x. And then now you can do the simplification. You can reduce them, and then so you have just sine x as your answer. Okay, it's a very enjoyable process. Very, very enjoyable process. Okay. Now there are things that are so unique that you know it has to be this way or the other way. Like whenever you see something like this, like pi over 2 minus x. Now we have discussed this last semester, but we didn't make a huge point out of this. Do you still remember that sine 90 degrees minus x is the same thing as cosine of x? If you say, wait, what? Why? How? I'm glad that you asked. So you can go ahead and make a right triangle and say this is your x. And just label this as ABC for the moment. Well, if this angle is x, what is the angle? How would you label the angle at the top? Well, you learn about all 3 angles inside the triangle to add up to 180, right? So the top angle must be 90 degrees minus x. So we say, well, let's think about this. Sine of that top angle, 90 degrees minus x, what is that? Well, opposite over hypotenuse, right? Sine of this angle at the top, well, opposite over hypotenuse. What about cosine of x? Adjacent over hypotenuse. So that's how we justify these identities. How sine of 90 degrees minus x is equal to cosine of x for this very reason. Again, do not just memorize. Know the reason behind it. That's going to make you very special. And I want you to be special. So this question, it is just changing sine of pi over 2 minus x to cosine of x. And cosine of pi over 2 minus x becomes sine of x. And that gives you cotangent of x. Now, it's up to you to put parentheses. I don't mind if you drop the parentheses around the x. That's okay. In terms of meaning and notation, it's not really a big deal. Okay. So now for question number 8. Okay, the reason why I want to go over question number 8 is because that involves some prior skills that you have learned in your Algebra 2 and first semester of PreCal. Now, in case you cannot see it, what if I give you something like this? A to the 4th minus b to the 4th. How can you factor this? How can you factor this? A to the 4th minus b to the 4th. Any recollection that you have done something like this before? Now, the answer is how many of you cannot see how it happens? Raise your hand if you cannot see how it happens. Everyone can see how it happens? Good, good. In case you don't know, this is how you see it. So you learn about a squared minus b squared is equal to a plus b, a minus b, this kind of factoring. So whenever you see the power that's not a simple 2, then it's this kind of play. All right. So that's how we handle this kind of factoring. And if you can recall this kind of factoring, you're like, oh, so this is just like secant x to the 4th minus tangent x to the 4th power. So it becomes, oops, sorry. Secant x squared plus tangent x squared. And then, well, actually, let me put it this way. I think that's going to be better. Secant square x, tangent square x, and then secant square x minus tangent square x. Okay. And now, again, can you associate something? Do you find something familiar? Yes. Now you can think about that, but the fact that you have these square, that should help you relate to another thing. The identity, the Pythagorean identity. Okay, which is what? 1 plus tangent square x is equal to secant square x. So you're like, wait, hold on. Hold on. Does that relate to this thing right here? Can you make use of it? And we're like, yeah, if you move the tangent to the other side, so 1 is equal to what? Secant square x minus tangent square x. So this thing right here is just 1. This is your answer. Okay, so that just becomes 1. So your answer is secant square x plus tangent square x. And well, I think that's our answer. Choice F. Can't do anything more about this. Yeah, can't do anything more. We'll just take that as our answer. Okay. And if you look at number 10, I think we have a very similar situation. Secant square x minus 1. Ooh. When you see a secant square x and also a 1, you are again thinking about, what is secant square x minus 1? We have tangent square x over sine square x. Now, I'm going to show you a couple ways of handling this situation. And you choose whichever way you're going to write it down. First, I'm going to show you my way. My way is this. I'm going to think about this in terms of sine x and cosine x because I can see how sine x could have something to do with this simplification process. So I'm going to write something down like this. That's my way. And the reason I write it this way is because the tangent square x can now become and I can see how the sine square x can be canceled out. So if I write it this way, I prevent myself going into a situation of a complex fraction because I don't want this to be a complex fraction. So cross them out. You have 1 over cosine square x, which turns out to be secant square x. Done. So that's one way to deal with this. All right. So if you like it, you can take it. Now there's another way you can do it, and this will involve complex fraction. So we may say, well, tangent square x becomes sine square x over cosine square x, and then the denominator is sine square x over 1. Now I would say if you know what you're doing, sure, you can do this. You can say, well, for both fractions, you have a sine square x in the numerator, then you can cancel them out. But if you don't understand, if you're not comfortable with this reasoning, then stay away from this. Only do this if you know what you're thinking. So the denominator just becomes 1, so we don't have to worry about it. So you have 1 over cosine square x, so therefore it is secant square x. Which one do you prefer, the first way or the second way? First? Second? Which one? First way? Okay. Well, anyways, I just want to make sure that you're exposed to these different ways of doing math. Okay. So now, so as I said, I posted videos for question 1 through 11, actually, 1 through 11, and why is it 11? Where? Oh, because the numbering went wrong over here. I wonder. So yeah, so I posted videos on those. So if you want to have somebody to walk you through doing all these problems, feel free. Play the video and do your worksheet. And now let's go to the second one. Now, what you see, it's a lot of basic algebra skills that are involved in this, on this topic. Like for example, can you see something special over here? A squared minus b squared thing, right? Because you have cotangent x minus cosecant x, cotangent x minus cosecant x. So you have cotangent x, cotangent square x minus cosecant square x. Right, and now the question is, wait, hold on. For this thing right here, does this equal to something? Think about what relates to these two things. Cotangent square x minus cosecant square x. Can you relate? Can you relate? So if you shuffle the terms around, cotangent square x minus cosecant square x is equal to what? If you shuffle the terms around. So if you want to keep the cotangent on the left, cotangent square x on the left, so you subtract cosecant square x, and then you have to minus the 1 over. So that means this is equal to -1. Again, you want to subtract the cosecant x to the left, and then you need to subtract 1 to move the 1 to the right. So that's equal to -1. Yes. I cannot hear you. Say again. Ah, that's a good thing that you mentioned. Now, what if you couldn't see this? Well, there's still a way out. It's just the way is longer. There's still a way out. So if you say, well, what if I did this instead? Is it wrong if I did this? Well, it's not wrong. It's just longer. It works. Okay. So you say, oh, well, I have a common denominator of sine squared. That means I can just subtract them. And you still ask yourself a question. Well, what's cosine squared x minus 1? Well, you've got to think about this then. Okay, you think about this, you're like, what is this? If I have to move things around, then I would have this. Now, be very sure that you're not messing up with the sign. Let's do a negative over there. So then you're like, oh, okay, so the numerator simply becomes negative sine square x over sine square x, which is still going to give you -1. So this is the fun, the joy of this unit, at least from my perspective, subjectively. There are always multiple ways to do the same math. And you have to analyze and think about which one is the most efficient route to take. Well, can you see how cosine squared? First, can you see how they're subtracting? Because they have the same denominator, so they're subtracting. Okay. Question. Okay. So basic math, like for this one. Okay. So we see 2 fractions. Well, what can you do with 2 fractions? What can you do with 2 fractions? Well, there are not many options. You're just going to common denominator. There are not many things you can choose, actually. So, so you multiply for the first fraction, you would multiply by secant x minus 1 over secant x minus 1. For the second fraction, you would write down, but they have the same denominator. But then because you multiply secant x plus 1 for both numerator and denominator. Yes? Middle school math right here. Except that it's now more fancy. So what does the denominator become? It becomes secant square x minus 1. A plus b, a minus b. And the numerator becomes minus 2. Yes. Because of the subtraction. So secant x minus secant x, gone. And then you have minus 1 minus positive 1. That's how you get the minus 2. Secant x minus secant x. And then -1 minus 1. That's how you get the minus 2. And then we say, hey, can you see something in the denominator? Does that trigger anything? Yeah, so you're like, oh, wait, hold on. I think I can think of something. I can think of this one. Now, throughout this few days, and I hope that you're not putting off all these worksheets and exercises until the very end. You've got to do it on a daily basis because you need the exposure on a daily basis so that you become very sensitive. You're like, oh, yeah, I remember this one. Secant square x minus 1 is tangent square x. So to make it the ultimate simplified or the simplest version, you will write down this as -2 cotangent square x. Okay. So whenever you see fractions, you're like, entertain the idea of common denominator. And my keyword here is entertain. We never know if it is going to work, but we must entertain the option. If you don't even entertain the option, if you don't even know there's an option for you, well, that's going to be a problem. Now, what about something like number 5? I mean, the next one. What would you do for the next one? Or what could we do? Okay, like I said yesterday, you always start thinking about what could we do, and then we think about what we should do. What could we do to simplify this? Any idea? Yes? Can you see something special over there if you think that way? So if you just entertain the idea of changing these two back to a sine x and cosine x, you would quickly see something like, wait a second, they happen to be the same denominator. And that's why you need your mental math. You got to see the possibility. Oh, I can see something. I can see that this is 5 over sine x plus 1 over cosine of x. And then you would take care of the complex fraction. So you're like, okay, so what about 5 cosine x over sine x plus 1? Say again? No, there's nothing to cancel the 1. There's a plus. There's an addition. So now, is there anything else we can do? We ask. Is there anything else we can do? No, it's a plus. There's a plus right here. So you cannot split the fraction. So that's not much you can do for this one. It's not something like we can greatly simplify to reduce it to a single term. Now I can entertain the idea of, now I could, don't write this down, but I'm just showing you that I can entertain the idea of multiplying sine x minus 1 and sine x minus 1. I can entertain this idea because I'm thinking that if I do this, I can get something simple in the denominator. But well, that would be sine squared minus 1, which is related to cosine square x. But it's not really that simple, simplified anyway. So nothing much we can do here. All right, do you think you can do this one? Again? The same question earlier. See if you can do this without referring back to the previous page. Okay. Practice your thought process. So if you absorb the experience from the previous question, from earlier question, then you would know that this is secant square x plus tangent square x, and then secant square x minus tangent square x. And then because of the identity that it's 1 plus tangent square x equals to secant square x. And if you manipulate the terms, you have 1 equals to secant square x minus tangent square x. This is essentially 1. So your answer is, ta-da, this. Okay, nothing more we can do. There's nothing more we can do. Okay, so next up, it's pretty fun. You got a term that's not a fraction. You got another term that is a fraction. What can you do? What can you do? McKenna? Yeah. So make them have a common denominator of tangent x. So the first term will become tangent square x. And then the second term still minus secant square x. So we ask the question, tangent square x minus secant square x is equal to, well, it's the same identity right here. So if you move things around, so 1 plus tangent square x, it's equal to secant square x. You want to keep the tangent square x positive. You want to subtract secant square x. That means you're going to move the 1 to the other side. Yes. How did I get what? Here? Because when you do the common denominator, what do? You do this, right? Common denominator, that's a denominator of 1. Okay, now learn how to compress these this kind of step in your mind. Okay, so we do expect students to not showing this, but being able to write this. So you have -1 in the numerator and then tangent x in the denominator. So the final answer is simply negative cotangent of x. Okay. All right. And let me go over the last one here. Well, the way you think about this, I think you might have to think about this. And this is a skill you need to start having for your calculus. Whenever we see something like this, we're like, what can we do? What can we do? A couple of things you can do. I will show you an easy one. Well, what's cotangent square x? right? If you have the identity known, stored in your head, that's what it is. And then you can actually factor it. So you can have cosecant x plus 1 and cosecant x minus 1. And can you see something already? Yes. This one? You change this. Look at your identity. The one with the Pythagorean identity involving cotangent. So if you're not familiar with all these Pythagorean identities, well, be familiar with them this weekend. Practice them. Practice. Practice. And so whenever you see all these things with the square, you start contemplating, wait, hold on. You will consider all these options. And that's why yesterday, what did I say yesterday? The first question is, what could I do? If you're not thinking about all the possibilities, you are stuck and you're doomed. But if you can consider the possibilities, they're like, oh, I can write this. Wait, hold on. What else can you do? Well, you can factor. Wait, hold on. If you factor, what can you do? Oh, they cancel each other out. So that is what we considered a simplified result. Okay.